Welcome to the video for lesson 3-6 for the 050 class, quantitative literacy. We're working out of the quantitative literacy book that we have. Hopefully you've done the prep skills for lesson 3-6. You'll notice we're working with proportions again. So proportions, and we're going to be solving. We're going to be using equation solving, and we're going to be thinking about conversion factors, which we talked about when we talked about unit analysis. So hopefully you've also read through the learning objectives and the introductory paragraph. We're really talking a lot about exchange rates for currency, but really that's a proportional relationship, and that's the fundamental thing that we're looking at. So go ahead and start the classwork. Read through the introductory paragraph here and then answer question 1. Return to the video when you're done. Okay, exchange rates. They explain that exchange rates, when you change from one country's currency to the other, the currencies have different values, so you don't get a one-to-one relationship. But there is a relationship. So question 1, using the exchange rate you found in the looking ahead portion of lesson 3-5, write the exchange rates as an equation. $1 equals how many Russian rubles? So dollars to rubles, I look that up, and I get $1 equals 75.18 rubles. You probably get something slightly different when you do it. So I will go ahead and put in 75.18. Go ahead and do question 2. Restart the video when you're done. Okay, write the rate above as a conversion factor with US dollars in the denominator. So if I want to see how many rubles I can get for $10, I would multiply 75.18 by 10. So 75.18 rubles per $1. And as we've talked about before, if I multiply that by $10, I would get 751.8 rubles. The dollars would cancel out because I would have dollars in the numerator, dollars in the denominator. So we're thinking about the unit analysis again. Go ahead and do question 3. I inadvertently did the first part of the table for you. But anyway, fill out that table and restart the video when you're done. Okay, now that you've done the table, well, obviously, first of all, if you exchange $0, you're going to get 0 rubles, which you could get by multiplying 0 times 75.18. 10 times 75.18 is 751.8 rubles. 20 times 75.18, do that on a calculator, but 2 times 750 is 1,500. 2 times 1.8 is 3.6, and I have to put a 0 in my tens place. Multiply that by 30, 2,255.4. double check that on the calculator. But you get the idea. Filling out the tables, not that much of a challenge. So hopefully that if you didn't get those numbers, you can figure out why and finish the table correctly. If we go to our next problem wants us to draw that draw a graph based on that table, and you notice you have to put in the scale on each axis. So you have to do a little bit of thinking about that. It looks like there are about 10 lines on everything. First of all, you want to think about what goes on the x-axis, what goes on the y-axis. I say x and y. We don't really need to label them that way. I should say horizontal and y-axis. So go ahead and do that graph and restart the video when you're done. Okay, if I go back to the equation, we're talking about exchanging dollars for rubles. The amount of rubles that we get depends on the number of dollars that we exchange. So my y-axis, the dependent variable, is going to be my rubles. And my x-axis is going to be my dollars. So if I think about this, I'm going up to do we go up to $50? Yeah, $50. So I need for my x-axis to go up to $50, and so I'm going to go by 5. So the first one is going to be 5. I'll put my 0 for the very beginning. I'm not going to put the first one because with the touch screen and my bad handwriting, you wouldn't be able to see everything. So I'm going to skip the 5 and I'll write the 10. The implication is that people understand that halfway between 0 and 10 is 5. Likewise, halfway between 10 and 20 is 15. And then I go 25, but I don't write it. I go to 30, 40, and 50. Okay. And let's go back. So we'll go ahead and I want to figure out my last one. So I'm going to add 15. So 37, 59. So I need to go up roughly to 4,000. And I've got 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16. So every 4 lines is going to be 1,000. So every, if I want to go up to almost 4,000, I have 16 lines. I basically divide 4,000 by 16, which means 250 per line. So if I skip a line, that's 500. 750, 1,000, 1250, 1,500, 1,500, 2,000, because I skipped 1,750. I skip 2,250 and I go to 2,500. Then skip 2,750 and I'm at 3,000. And then 3,500. And hopefully everyone can see every 2 lines I go up by 50, so the reader can interpret that the top is 4,000, which would be okay because we're not going up to 4,000 anyway, so don't necessarily need that last one. So now I plot my points. Of course, 0, 0. So I'll have a great big point right here. 10 and 750. So $10. And 750 is halfway between 500 and 1,000. And you'll notice it's not exactly 750, it's 751.8. But based on the level of accuracy of the graph, I can't really get any closer than 750. So that line covers 750, that dot covers 750, and it covers 751, and it probably goes up to 760 and down to 740. So I'm thinking of it in terms of 750. Likewise, at 20, I get 1,500. And that dot is big enough that it's going to cover 1,503.8. We'll take the 2255 for 30, and I'll go up to 22. 2250 is halfway between 2,000 and 2,500. And there again, there's 250 rubles in between each line. That dot is big enough that it's going to cover 2250. It's also going to cover 2255. So by doing the graph, we're really kind of approximating the value. And that's okay, because we're really trying to develop relationships. Right now, we're not trying to do this. With a graph, you're not doing it super accurately. You do it super accurately with the math. And ultimately, at $50, we get $37.59. $50. Actually, 3,759. Still pretty close to 3,750. Okay. I think that's what we needed to do for question 4. Make sure you mark the scale on each axis, include a verbal label that shows the quantities, and quantity represented on each axis. So we've got dollars on the x-axis, the dollar axis, and we've got rubles on the ruble axis. Okay. And we've got our scale. Okay, so go on to question 5. Find the slope of the line. Once you've done that, restart the video. So I got my line. To get my slope, as we've done before, we take our y2 minus y1, and I think of that as change in y because I know subtraction gives me change, divided by our x2 minus x1. And you see the points I've picked. My y2 is going to be 2255, I believe. 2255.4. And the one before it is 1503.6. My x2 has to go with my y2. So my 2255, the x that goes with that is 30, or the dollars that goes with that number of rubles is 30. And the dollars that goes with 1503 is 1,503.6 rubles corresponds to $20. So my slope is going to be 751.8 rubles per $10, which then reduces to 75.18 rubles per $1. So I found my slope, and what does it represent? Well, you notice that's exactly the number of rubles that we could get for $1. So the slope of the line actually represents rubles per dollar. Go on to question 6. Once you've answered question 6, restart the video and we will discuss it. Okay, write an equation using x and y that calculates the rubles y. So now they're calling the rubles y. Okay, we can do that. You can trade x American dollars for which variable is the input and which is the output. So first of all, we want to think about that last part of the question. Last part of the question, which one's input, which one's output? We're calculating rubles. That's going to be our output. So y is our output, the rubles. We're starting with a number of dollars. And if we go back to how we write equations, we multiply x times the slope of the line. And then we add the y-intercept, which in this case was 0, because if we get 0, we exchange $0, they're going to give us 0 rubles. Actually, we can just leave that out. There's another way you can think about this. We already decided we're going to multiply dollars times the number of rubles. If x is the number of dollars, we're going to multiply that by 75.18. 75.18x means once you figure out what x is, multiply by 75.18. And when we do that, we know we're going to get rubles. We know that answer is going to equal rubles. So we can construct the equation in that way. Do question 7 really quick and then restart the video. So use your equation to find the current cost of a Big Mac in Russia using 2.15 dollars. So we're assuming a Big Mac costs $2.15. We're going to multiply that by 75.18. And I'm going to the calculator here. $75.18 times 2.15. Whoops. Hit the equal too many times. 75.18 times 2.15. 161.63. So y equals, the number of rubles equals 161. I'm going to round it off to the number, the nearest ruble, because I don't know how rubles are divided up. I'm going to call that 162 rubles. Question 8, use your graphing calculator to verify the table and graph from question 3 and 4. We're not using graphing calculators. You could do that on Desmos.com, but I don't see a lot of benefit in it at this point. So go on to question 9. When you're done with question 9, restart the video. Okay, I kind of gave away question 9 when I talked about the equation, writing the equation. How many rubles do you think you get if you exchange $0? You get $0, you get 0 rubles. Restart the video once you've looked at question 10. Okay. If you double the number of dollars you are exchanging, what do you think would happen to the number of rubles? If you exchange twice as many dollars, you get twice as many rubles. Question 11. Come back when you have thought about that. Question 11. You triple the number of dollars, you get 3 times as many rubles. And you're actually supposed to look at the table. If we go back to our table, if we go from 10 to 20, we get twice as many rubles. If we go from 10 to 30, we get 3 times as many rubles. You may not see that. You could see that though by taking 1,503.6 divided by 75.18 on your calculator. You should get 2. You should get 3 when you take 2,255.4 divided by 751.8. If you don't, email me and let me know I messed up the table somehow. When you answer question 6, restart the video. Okay, if you will cut the number of dollars you are exchanging in half, what do you think would happen to the number of rubles? If you exchange half as many rubles, you get half as many dollars. And again, you could find an example from the table. You exchange half as many dollars, you get half as many rubles. Looks like we have a did you get it now? Not a did you get it. More of a discussion. And it's important that you read these. So take a minute to read through this, and then we will discuss it. Okay. Now that you've restarted the video, here's some conclusions. $0, 0 rubles. Dollars goes up, rubles goes up by the same factor, which means you're multiplying by the same thing. You multiply your dollars by 1.5, you multiply your rubles by 1.5. You increase your rubles by 25, increase your dollars by 25%, you increase your rubles by 25%. The amount of dollars goes down, the rubles go down by the same factor as well. And what they're really wanting you to understand is some of the vocabulary here. We're saying these two quantities very directly. So if they go up proportionally, one goes up, the other goes up proportionally, we say they vary directly or they are directly proportional. And we call it direct variation. We say this is direct variation. And in the little summary here, you see what they're talking about. They're showing you algebraically, they're showing you in the table, and they're showing you on the graph what it looks like. And you'll see on the graph it goes through 0 because when they vary directly, there is no y, or the y-intercept is actually 0. So in direct variation, the line goes through the origin, and then it's a straight line then. Okay. Now there's a did you get it? So if you did not get it, send me an email, unless you can figure out why, obviously. At any rate, let's move on. I think we go to the group work now. So yeah, group work. Look at question 1, then we will discuss it. Restart the video once you have an answer. Question 1. Earlier in this unit, we put a lot of energy into modeling the cost of taking a cab in Las Vegas. There was an initial charge of $5.10 plus $2.60 per mile. Is this an example of direct variation? Explain. You'll notice in the direct variation, if you double one number, you double the other. Because of the $5.10, when you double the mileage, you do not double the total cost. You double the cost per mile, but both times you pay $5.10. So it's not an example of direct variation. Another way to put it, direct variation, as we said before, has no y-intercept. It has no initial value, initial charge in this case. So this is not direct variation. Restart the computer once you've thought about question 2. Okay. Buying gasoline. Do you think the amount spent at a gas pump and the number of gallons purchased are quantities that very directly explain? So, once again, I think gas last I saw was $1.89. It's down to $1.68 now. So if you buy 1 gallon, you pay $1.68. If you buy 2 gallons, you pay $1.68 for each gallon. For every gallon you buy, you pay $1.68. There is no initial charge, so this is direct variation. Restart the video once you've answered question 3. Let's say you stop at the local gas station just to buy an energy drink and don't pump any gas. How much would you pay for 0 gallons of gas? You pay $0. If 5 gallons of gas costs $1.10, answer questions 4 and 5. Restart the video once you've answered question 4. How much would you expect to pay if you double the amount purchased to 10 gallons? So 5 gallons cost $11.10. 10 gallons would cost twice that, $22.20. Restart the video once you have an answer to question 5. Question 5 is a little harder to do in your head, but I'm going to break it down. So $10, half of $10, because we're 2.5 gallons is half of 5 gallons. So I want half of $10, which is 5. Half of $1 is 50 cents, and half of 10 cents is 5 cents. So if I buy half as much, I pay half as much. Okay, go on to question 6. Question 6, now a more interesting question. How much would you expect to pay for 15.2 gallons of gasoline? That's not quite as straightforward. First, we'll attack this problem using proportions. Then we'll see if maybe it's more efficient to use variation. So in lesson 3-3, we learned that an equation stating that 2 ratios are equal is called a proportion. Solve this problem by setting up a proportion. So we need 2 ratios. So the first ratio, we're using the same data from the previous question. So when I paid $11.10, I got 5 gallons. I want to know how much I have to pay. And you notice when I said how much, I put the X. How much I have to pay for 15.2 gallons. Okay. Ratio should compare 15.2 gallons of gas to the cost, which is what you're trying to find. And we want to solve this problem. As we've discussed before, some people do the fish. So they multiply 5 times X, and they multiply 11 10 times 15.2 gallons. And then they divide both sides of the equation by 5 gallons in this case. I like to multiply both sides by 15.2 gallons. Because I know when you multiply X times 15.2 and you divide that answer by 15.2, you're just left with X. And I know from my understanding of equality and the multiplication property of equality, if I multiply the right-hand side by X, I'm going to change the value of the right-hand side. It won't be equal anymore unless I multiply the left-hand side by 15.2 also. Then I make that answer equal. So I have 15.2 times 11.10 divided by 5. And I get 33.74. I'm going to round it off to the hundredths because I know that dollars are broken up into hundredths. Okay. The next questions we're going to, or eventually we're going to be working at that similar problem in a different way. This is how we did proportions. We will look at different ways to tackle this though. So did you get it? If you got it, let's go on. Otherwise, send me an email, and we can see if we can figure it out. Question 6. Let's go back to that same gasoline problem using direct variation. Didn't see why that might be a good idea. First, write a direct variation equation describing the cost C of buying G gallons of gas. So cost is going to be what we're calculating, and it's going to be using G gallons of gas. To do this, we need a slope. You noticed before we had our direct variation equations have a slope, but they don't have a y-intercept. Slope is also really, we found it's also a unit rate. And we found when we did unit rates, a unit rate in this case is the price per gallon. And price per gallon turned out to be $2.22. So price per gallon actually came from $11.10 per 5 gallons. And we know if we multiply the number of gallons by 222, we're going to get the cost. And so we can say 222 G equals C. And actually, I'm going to call that dollars per gallon. So the gallons will cancel out when I multiply by the number of gallons. Okay. So, question 8, restart the video once you've done question 8. 5 gallons cost $11.10. So plug these values into your variation equation. We're going to check and see if our equation works. So C equals $2.22 times 5 gallons. And here you can see the dollars per gallon. And as a result, have gallons divided by gallons. My answer is just going to be in dollars, which is what I want. And 5 times 2 is 10. 5 times 20 is 1. So I have 11. And then 5 times 2 cents. Sorry, 5 times 20 is actually 100 pennies, which is $1. And 5 times 2 cents gives me 10 cents. So I know that my equation worked for 5 gallons. Restart the video once you've done question 9. Question 9. Now you can rewrite your variation equation so that the only unknowns in it are C and G. I honestly don't know what they're talking about. Because that's what we wrote before. Okay, at any rate, let's go on to question 10. Restart the video once you've done question 10. Question 10, what does the constant of variation you found describe about buying gas at this station? The constant of variation is actually the $2.22 per gallon. That's what they mean by the constant of variation. And what it says about the gas station, if for every gallon you buy, you pay $2.22. Question 11, restart the video once you've answered that. Question 11. If we use our equation, we would get 33.74. So we're seeing that equation, just a different way of thinking about the problem. We get the same answer. Which method of finding the cost of 15.2 gallons makes it easier to complete this table? Pick one method and explain why, and fill in the table. If you don't understand that, just fill in the table. Basically, however, the easiest way you can think of to fill in the table. Restart the video once you've done that. And what they're really hoping you will say here is that it's easier just to multiply the number of gallons times 2.22 rather than writing the proportion every time. So with the direct variation, you can just multiply one quantity to get the other. You don't actually have to set up the proportion. You don't have to cross multiply, which some people now are calling the fish. If you know every gallon costs $2.22, you just multiply $2.22 by the number of gallons. So 3 gallons cost $6.66. 0 gallons cost $0. Multiply 6 times 222. Multiply 9 times 222. And I've just been adding 6.66. If I wanted to finish the table, I would multiply 12 times 2.22 on my calculator. It should be 14 plus 140, 15, 50. No. Yeah, I'm sorry. 24 plus 240, 26.64. And you'll notice that's twice the amount for 6 gallons. I could add another 660. Hopefully you get the idea. Restart the video once you've answered question 13. Question 13, what would it cost you to put $11.55 gallons in your car from this pump? Okay. $25.64. And the gallons cancel out as before. Okay. So if you spent $40 on gasoline at this pump, how many gallons did you get? Restart the video once you figured that out. So if you spend $40, that's your cost. You may not have written it this way. That's fine. You may have just figured out that you want to divide by $2.22. You want to see how many 222s are in $40. That's really what we're doing. And it does make sense to do it that way. That's fine. When you have an equation, though, you say, okay, yeah, I am going to divide $40 by $2.22 per gallon. And if I do that to the left side, I do it to the right side. Because when I change the 40, it's not going to be equal to 2.22 G anymore. But if I change the 2.22 G in the same way, then they will still be equal. Which is nice, because if I have 2.22 G divided by 2.22, I'm just left with G. And 40 divided by 2.22, 18.02. Okay, so solving problems with direct variation, kind of a summary here. Go through it really quickly. Okay. So two quantities that vary directly, and you think about it, it's for every one of these, you have so many of these. For every gallon of gas, you pay this many dollars. For every dollar you have, you get this many rubles. That idea really identifies the direct variation. Okay. Figure out which one is input and which one is output. And that really depends on the information that you have. Um, any direct variation really can go either way. It just depends on the perspective of the problem. So use a given input and output to find the constant of variation. K, we're just calling that the constant of variation. That's kind of a weird way of saying this, but the input and the output in the gasoline problem, we input the gallons, we output the cost. We picked a cost and number of gallons, and we figured out how much it was for 1 gallon. That's really how you get the constant of variation. How much is it for one thing? How many rubles for $1? How many dollars for 1 gallon? Rewrite the equation in the form y equals kx. So if we wanted our cost, we multiplied by the number of gallons. We just wrote an equation that said that, where we put C for the cost, G for the gallons. We just wanted to communicate that we're going to multiply $2.22, which is our K, times the number of gallons. And you notice it says write units on Y, K, and X. Think about dimensional analysis. We tried to do that. Then use your equation to solve the problem. It's really the same as using the unit rate to solve the problem. If you know how much gas costs and you know how many gallons you get, you're going to multiply the gallons times the unit price. That's really all that you do. When you use that equation, you're really just doing that. Okay? So it shouldn't be, don't make it harder than it is all I'm trying to say. You know what to do. You're just learning to work with an equation now. Right? Restart the video once you've looked at question 15. Another area where we have direct variation, you get paid hourly at your job. Total amount of money you earn varies directly with the number of hours you work, unless you get a bonus, which doesn't happen very often anymore. Let's say you worked 14 hours last week and made $163.80. Write a variation equation describing your total pay, P, in terms of hours worked. What we found, we really want a unit rate. All our constant of variation, as we're calling it, is really a unit rate. So we're going to get dollars per hour. 163 point, now I've forgotten, 80 divided by 14, $11.70. I'm going to write per hour. That helps me remember to multiply by the number of hours. Okay. So write a variation equation describing your total pay, P, in terms of hours. I'm going to multiply $11.70 per hour times the number of hours. That's all I have to do to write the equation. Then use it to find how much you'd make for working 20 and 25 hours. The equation tells us to multiply number of hours times $11.70 per hour. Pretty well, you probably knew that you were supposed to do that anyway. So 1170 times 20, 220, 234. I'm going to check it. 1170 times 20, 234. So when we show our work, we rewrite the equation. So we write the equation, and then just write our answer. P equals, I forgot now, 234. So our pay equals $234. Do the same thing with 25. And then write your answer. You can double check that on the calculator. I won't bother with that. Go on to the did you get it? If you don't get it, let me know. But it should be pretty straightforward after what we've done. And go on to question 16. Restart the video once you've done question 16. So 16a, solve the direct variation equation y equals kx for x. This is something that people always struggle with, and I think probably some of you are still struggling with it. That's okay. When we had y equals x, and we plugged in a value for y, was it 1155? Any rate, we divided 1155 by 2.22 to see how many gallons. Was it $15.2? How many gallons was that? I don't remember. Point is, you divide by that number. So we have y equals kx. I'm going to divide both sides by k. Just give myself a little bit more room. I'm going to multiply by 1 over k. 1 over k is the reciprocal of k. We also call it the multiplicative inverse. Because k times 1 over k, the k's cancel out, you get k over k. That reduces to 1 because you have the same number in the numerator that you have in the denominator. So 1 over k times y equals x. Question B, what does this tell you about the ratio, fraction in this case, involving x and y? Hint, does k vary in a direct variation equation? So in a direct variation equation, k does not vary. So if I'm going to have, oh, I'm sorry, I did this wrong. I wanted to solve for k. I solved for x. Wasn't thinking correctly. What I did was valid. It was good for you to see. We want to solve for k. Which means I have to multiply both sides by 1 over x. Multiply by 1 over x. So k equals y over x. And since we know that k doesn't vary, we know that y over x does not vary. This is just an abstract way of saying what we initially said with the rubles. If we take rubles divided by dollars, we're always going to get 75.1. If you took the gallons, the dollars divided by gallons of gas, you would always get $2.22. So some of the advantages of using direct variation equation rather than a proportion. Go ahead and read that. So proportion you have to write every time. With the equation, you just plug the number into the equation, or you literally just multiply by the constant. Basically, with an equation, you've already done the cross multiplication, or you've already solved the equation, or the proportion for what you want. Okay? With the table feature on your graphing calculator or spreadsheet, you can speed up the process even more when you have direct variation equation. It is very easy to program those into a calculator or into an Excel spreadsheet. We don't need to worry about that though. And 3, with proportions, you never actually see the conversion factor. Look at the gasoline problem. The variation equation shows us easily that gas was $2.22 per gallon. If you write a proportion, you don't necessarily see that. You'll see it probably as you're doing the calculations on your calculator, but it doesn't really show up on your paper because it's all done in the calculator. Okay. Let's go on to question 17. Restart the video once you have finished question 17. Okay. So somebody gave the author his own bobblehead doll. He calls that Mini-Me. So it's a 1/13th scale model. That means 1 unit on the doll is 13 units on the person. So how tall am I in feet and inches? Okay. Either set up a proportion or use an equation of variation. So 2 ways to do this. So 1 over 13 equals 5.82 over x. The other way to do it is set up the equation. So the equation 1/13th, that means whatever the person's height is. So whatever is on the person equals 1 over 13 times the doll, the bobblehead doll. Okay. So we can write the equation. If I solve the proportion, I end up with, I would flip it over. Let's do that. 13 over 1 equals x over 5.82. Multiply both sides by 5.82. Hopefully you remember that's 5.82. At any rate, x equals, we'll figure that out in a minute. With our equation, we want to find the, and I said the equation wrong. The doll is 1/13th of the person. So if I want the doll, I take 1 over 13 times the person. But I want the person. I know the doll is 5.82 inches tall, and that is 1/13th of the person's height. Here I multiply both sides by 13. And I still end up with 5.82 times 13. Either way I do this. times 5.82, 75.66 inches. And I don't really have enough space to do that in feet and inches, but to get feet, I'm going to divide that by 12. So he's over 6 feet tall. So I can say 6 feet. And now I just need to know how many inches. Okay. I have got a decimal number of feet. A lot of people would call that 3 inches. Some people would call it 30 inches. Neither one is really right. But I'm just worried about inches now. So I'm going to subtract the 6. Because I've got the feet. Now I have 0.305 feet. I'm going to multiply that by 12 to get the inches. So actually 3.66 inches. The actual mini-me from Austin Powers movies is 32 inches tall. If he had a bobblehead doll of the same scale as mine, how tall would it be? Okay. So after you've thought about that question and come up with an answer, restart the video and we will discuss it. So 32 inches tall, and the bobblehead doll would be 1/13. So really we just take 32 inches times 32. If you want to do, you can do the times 1 divided by 13, 2.46 inches. Try question 19. Restart the video once you have an answer. The sales commission earned by a saleswoman varies directly with her gross sales. So in one quarter, her commission was $7,200 on $180,000. So what is her sales commission rate? So she sold a lot of stuff. So sales commission usually comes out in percent. So commission rate, we go to percent because we want to know how many dollars we make per dollar that we sell. So that way we can multiply by the number of dollars we sell, we get our commission. So we actually want 7,200 divided by before I'm going to equal it though, I'm going to multiply by 100 to get percent. So I really got 7.2 divided by 180. And I multiply that, I actually get 720 divided by 180. I'll go through the full way. 7,200 times 100 divided by 180,000. She gets 4% commission. Use the sales commission rate to write an equation relating the commission earned to the amount of gross sales for that quarter. Make sure you describe what any letters you use represent. So take a shot at that. Once you've got an answer, restart the video. So we have to write an equation, and it tells us what it's relating. The commission and the gross sales. You'll notice we're using G in a different way than we used it before. That's okay because we're defining what we're using. Gross sales. Okay. So now we write the equation. We're going to take our 4%, we'll change it back to a decimal and make it 0.04, but then we're going to multiply it by the gross sales. So to get our commission, we take 0.04 times the gross sales. Use your equation to complete the table of values. So basically just multiply everything times 0.04. 40,000 times 0.04, 1,600. You can just do that for the rest of the table. Let me know if you have any questions. Return to the video once you've answered question 22. Earlier we observed that as the number of rubles goes up, so does the number of dollars. We also saw that as the amount of gas you buy goes up, so does the cost. Is that always the case? If the constant of variation is negative, what is the effect on y if x increases? Explain. Studying the generic equation that describes direct variation will help. So what if we have y equals negative 3x? If I look at a table, negative 3 times 3 is 0. 1 times negative 3 is negative 3. 2 times negative 3 is negative 6. And then negative 9. So if I have a negative coefficient, then things are going to go down. So look at question 23. Restart the video. Actually, do 23, 24, and 25. And restart the video once you have answered those questions. In question 23 through 25, decide if the graph illustrates a situation where y varies directly as x. Explain your reasoning. So in question 23, it varies directly. Question 25, it varies directly. Since I start at 0, if I double my x, I'm going to double the amount that y has gone below 0. In question 23, if I double my x, I double my y. But in question 24, does not vary directly. It does not vary directly because it does not start at 0. If I have this point and I double it, I haven't doubled X because they both include this constant value at the beginning. So 24 does not very directly because it has the y-intercept. Okay. That kind of wraps up the work for lesson 3-6. As you know, we don't do the technology. Online practice is the ALEKS that we do. You do need to be doing your ALEKS. And then the applications are the due for homework. So do the applications in 3-6. If you want to write those on your the pages in your book, take a picture and upload it to the D2L. I will take a look at those. I will see you for lesson 3-7. Thank you.